page 47 of the notes, and I think we stopped somewhere in the middle of sample problem 6.1. In sample problem 6.1, now and the first step is uh, to consider A, B, C, D, E as a rigid body and determine the support forces here. Determine the support forces here. And this part is the same as chapter 4, and the examination on Friday will cover chapter 4, so please, you should be able to do this, okay? You should be able to do this. Now, and after we determine the support forces, we go to determine the forces in each member. I will demonstrate. I will do one step, and you can read the textbook for the other steps. Now we go to we consider equilibrium at joint A. Now remember, and in joint A we have two members. We have two members connecting joint A, which is AB and AD. I should write here. AB and AD. Now, if we only consider joint A, and we will have tension in member AB and tension in member AD. Now, remember the forces go away from the node. Okay, the forces go away from the node. Now we have it's okay. Now we have the free body diagram of node A, and how many equations can we write from here? Summation F equal to 0, because it cannot rotate, so we don't have the moment one. How many? We have summation F equal to 0. So how many equations can we write here? 1, 2, or 3? Because it's a 2D problem, we have two equations. So we have summation Fx equal to 0 and summation Fy equal to 0. Okay. Now, and let me put it. We have two ways doing it, and this is this one way. And for this angle theta, and do we know the value of beta? I think so, because we have this figure, and theta, the angle theta is this angle. So we have tangent theta equals to 3 over 4. It's okay. It comes from this. Figure. And I'll come to the equations, and we have summation Fx equal to 0 and summation Fy equal to 0. For summation Fx equal to 0, what do we have? We have TAB plus TAD cosine theta equal to 0. And for summation Fy equal to 0, remember these two, both of them are going to the right, so both of them are positive. Both of them are positive. Okay, because these two are going to the right, and because we have positive to the right, so we have positive and positive here. Next, we have summation Fy equal to 0, so both of them are going down. Both of them are going down, so we have minus 10 kilonewton minus TAT sine theta equal to 0. Therefore, okay, you can write it down first. Right, yeah, thank you. So sorry that I made this wrong. So tangent theta is equal to 4/3, I think. Yeah, thank you. Oh, I made the same mistake last year, but nobody reminded me. So nobody told me, but I made the same mistake last year. Okay, and it's okay. Now, thank you for pointing it out. And so the next step is to solve. We have two equations and we have two unknowns, so we can calculate. So we will know TAB is equal to plus 7.5 kilonewton, and TAC is equal to minus negative 12.5 kilonewton. And so the mathematics is done here, but to write down the answer, we will have one more. We need to have one more step. And now, for what does it mean by positive and what does it mean by negative here? For the forces, if we calculate after calculation, if we get a force that is positive, what does it mean? If the force is calculated, if the force we get is negative, what does it mean? Now we go to the last page. We go to the last page. Oh, sorry, the last page here. So for all these TAD and TBD and so on, if the force we get is positive, it means it is in the member is in tension. So it is the force is pulling the member. But if the T is smaller than 0, it means we have compression. Okay. So here we have answers of we go back to sample problem 6.1. Now if we have TAB is if we have TAB is larger than 0 and TAD smaller than 0, it means this one is in tension and this one is in compression. Therefore, to write down the answer, we use it this way. TAB is equal to, sorry, TAB is 7.5 kilonewton bracket T. And for TAD, it is 12.5 kilonewton bracket C. Or bracket is that one. Okay. Now for if you get the tension value as larger than 0, then it is in tension. And if you get it as TAD and we get the value as smaller than 0, it means it's compression. And one important note that I will let me do it once more, and I will remind you of one important thing. And so is that okay? So if from here by considering equilibrium at joint A, we can determine TAB and TAD. Now and so we let's take these two members, and now you need to do. Now we need to do the rest 1, 2, 3, 4, 5. Okay. Now let me do it once more, and write down the equations, and you can do the rest. Next, we do it on we do the calculation on joint D. For joint D, and for joint D, we have how many members connect with joint D? AD, BD, and DE, three of them. Okay, so we have AD, BD, and DE. It's okay. Now, and do we know anything now from for the forces? Because we have three members, so we have three forces. We have TAD, TBD, and TDE. And I'm sorry, I made it wrong. TAD. So we have three unknowns. Or do we know anything from here? Do we know anything of these? We have three unknowns, but do we know anything by now? TAD is known now. So TAD is equal to minus 12.5 kilonewton. Okay, and this angle is theta, and this one is also theta. It's okay. Now we can from here we can write summation fx equal to 0 and summation fy equal to 0. And then you do the rest. Okay. Um, and then you can, and then you do the rest. And from here, it is we have such an, you can say, SOP for this kind of problem, and you do it one joint by one joint. And the the common mistake that your seniors had in the past was, and you we can I first go you can go to the last page first. And for this kind of problem, that the most common mistake your seniors have had was like that. And sometimes we know some of the members are in compression. For example, for this problem, sometimes I know this one is in compression, and your seniors would just will write the arrow, draw the arrow into the member. Do not do this, okay? We assume all members are under tension, even you know it is in compression, okay? You assume it is in tension, and then you get a value smaller than 0, and then you know it is compression. In this SOP, please assume all members are under tension and all forces are going out, and then you will usually be okay. Okay. Now, and this kind of problem is not difficult, but I will say it is for problems in chapter 6. This is not difficult, no. But I would say I will use a word in English. It's cumbersome. Yeah. It's cumbersome. Okay, it's not difficult, but it's cumbersome. That you need to for this problem. We have how many joints do we have? We have A, B, C, D, and E. Now you need to do it for joint A, for joint B, and then for joint A, D, B. Probably you need to do it on joint E as well, and then you need to do it 4 times. Okay, A, D, B, E, and then you need to do it 4 times. For the next sample problem, to determine the members, the forces in all members, we need how many joints do we have in the next problem? Let's see. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. So you need to do it like at least 6 or 7 times to determine forces in all members. So it is not difficult but cumbersome. So although it's not difficult, but do your homework and do as many exercises as you can. It's okay. It's not difficult.